The best way to describe philosophy of science is it's a discipline, just like physics would be a discipline or mathematics would be a discipline. Again, I said, there's still of some interest to me. But then I realized that doing physics was not to understanding physics, it was two different things. There's an equation, there's a graph, there's some English words in between. So I asked a very simple question to myself. All my work I've done is for trying to answer questions to myself. I asked the question, how do scientists, how are they expected to read this book?
So touching upon something you mentioned in the beginning, what is the concept of truth in science? Because what seems to be true today can be disproved tomorrow. And what seems to be impossible today becomes possible tomorrow.
A quick answer to that is, of course, the fact that the talk I gave at IISc Bhopal sometime last year was triggered by some of these questions. And it was called Truth in Science and Truth About Science. And, I don't want to deflect the question by saying people can watch that if it is there. I don't know if Bhopal has a recording of it. But the point I began with by looking at different types of truths in science. There's not one type of truth in science. There are very many different types. One example is mathematical truth is very different from what you call as truth in physics and truth in chemistry, which is different from truth in biology. So truth itself, although people keep saying scientific truth, as if there's one type of truth, it's not true. And that truth, which keeps changing, could be empirical truth, but even that has foundations which don't change. Nothing has changed. I mean, I often, in many of my workshops with children and so on, we begin with everybody in the class will say 2 + 2 = 4. And that's all we talk about. That's the best way for me to talk about truth and understand what is truth and how it is formed. 2 + 2 = 4 has not changed at all. And it's interesting to understand why. What is it about the type of truths which are present in science? So there is empirical truth. There is truth of theories versus truth of propositions, and versus truth of certain elements, concepts within that proposition, and so on. So when you dismantle the whole structure of truth in science, there are different implications. That's, for example, truth is something, again, which philosophers have spent a lot of time on. Just to give you very quickly a way to understand this, you would have a theory of truth, for example, like the correspondence, which will tell you truth is that which matches with the world. That's the only definition of truth. What do I mean by truth? Truth is not something, I don't know what it is. All that I can tell you is, if something is true, then it matches with something. It corresponds to the way the world is. So that's a particular kind of way of understanding theories of truth. And then you have a coherent theories of truth, which is truth is nothing but consistency. Something which is very important also in the context of mathematics, because mathematics, there are no numbers outside which I can go check. Like suppose I tell you apple is sweet, and it's true, let's say. I know there is an apple, I can go taste it and I say, oh, it's sweet. So there's a correspondence between what I'm saying about the apple and the way the apple really is. But when I say 2 + 2 = 4, or d by dx of sine x is cos x, I'm not really seeing those objects out in the world and go taste sine x and see what qualities they have. So a lot of mathematical truth is self-consistent truths. They have, and the greatest way of expressing this, of course, is the fact that whatever complicated mathematical equation you may have, the only quick way to check at any time in the proof whether you are on the right path is if it does not violate 1 = 1. You put values anywhere and you know that you're not violating, a tautology, what is called a tautology, A = A. I mean, that even kids who are unborn will know. Yeah, of course, A = A. What's A is not going to be equal to B. 1 is equal to 1. What's a big deal about it? All of mathematics is built on that structure. Okay, that's a thing which is very made famous by Wittgenstein and others. But the point is, so it's a very different type of theory of truth. Then you also have pragmatic theories of truth, which is like your engineering examples. A lot of things are true, but in terms of truth because something works. Not truth because it corresponds to something or it coheres and so on. So there are different types of truths which actually operate even within science. And you may not, and I think it is science, the great strength of science is its capacity to accept that, yeah, what I call as true today may turn out to be wrong, in the sense of the fallibility of scientific knowledge. But even within that, there are many things which they will not accept as wrong anyway. You need some underlying structure which does not change much. And that's why the scientists tend to run to mathematics all the time. Because if the scientific truths seem to be changing so much, what doesn't change? I mean, look at the truths of classical physics and quantum physics are so radically changed, right? I mean, absolutely changed in terms of what you may call as a truth. I mean, even the fact that a particle is not a particle can also be like a wave, a great change of the truth. But what doesn't change in classical and quantum physics is the fundamental mathematical structure. The interpretations of it may change. You're still working with your energy equation, kinetic energy plus potential energy equal to total energy, which is what becomes your Schrodinger's equation. You say, wow, what is this? Your underlying base has not changed, that structure. So that's why maths gives them that underlying structure, that safety blanket, they can run into and hide inside. Because you can then not answer inconvenient truths about what is really true about physics and chemistry and stuff. But having said all that, all I'm saying with this is that the capacity for science to have opened out the kind of objects and the kind of narratives about the world is astounding. It's really astounding. No other human practice has come close to that. The question is, how do we understand it? That's all.
Having talked about the concept of truth in science, I would like to ask you about its logically opposite counterpart, that is false statements. In your book, What is Science? While discussing Karl Popper's perspective of science, you mentioned the falsifiability of scientific statements. In science, proposing empirically stronger statements and theories makes them more open, vulnerable to being falsified. Still, such ideas are more beneficial compared to more general statements that are easily verifiable. What are your comments on this trade-off? Should a scientist play it safe and focus on being correct for a longer time, or aim for braver statements that are more useful but are vulnerable to being proved wrong in near future?
Yeah. Very good question again, because a lot of scientists tend to, just like the security blanket of mathematics, they also have a security blanket of falsifiability. You tell them anything about science, oh, no, it's falsifiable. It's not like the other things. So it's true. Falsifiability has a lot of currency within science, okay? I remember this, there's this big controversy about, remember this paper which was published from NCBS, and there's some fraud questions around it and so on, and they had to retract it. And one of the people who was responding to that was saying, no, we teach our students falsifiability, so they're all ethically trained and all that. And I think that's quite absurd, reading of falsifiability and its connection to ethics. The point about falsifiability is that it's a very powerful idea, Popperian idea. But when you practice science, when you write your own papers, and you probably have already, but I'm just saying as it becomes your full-time profession, one of the tricks which I've often heard, which my own professors have told me, especially in theory, that when I'm proposing a new theory, okay, it's great if the predictions, etc. come. But if things have not happened for some time, all that I have to do is change my parameters such that you will discover the particle I am postulating at an energy level which you will reach 10 years from now, not now. You'll always keep it right outside the boundaries of experiments, right? Because the amount of science in which this is done is far more than science which is falsifiable. So let me put it this way. Out of 3 million papers published every year, which is a mark of what scientific research is. They're all published in good journal, all refereed journals, and they're published. 3 million. You pick up 3 million of them and see how many of them are talking about falsifiability or are falsified themselves. That model is a classic model which holds as a general idealized picture for the whole of science, not for the doing of science in day-to-day practice. In everyday practice, most of science is least interested about falsifiability. It is interested in producing new narratives. It's interested in producing new results, new possibilities. It's the larger meta science theory. It is not that practiced by scientists, but others who try and see why some theory survived, why some theory didn't survive, that you start discovering these patterns of falsifiability and so on. I have not seen it as part of scientific practice in the way they think this is what it is. But it's still nevertheless a very important regulative principle for scientific practice. I still think it's an important idea to hold on to. And also there are various other, philosophers of science have discussed a lot about it, and there are various other problems coming from this, that falsifiability cannot exactly prove or disprove one statement. It can only prove a network of things which could have been wrong, etc. So it's a little more complicated than just saying one statement is either proved or disproved in that sense.
Thank you, sir, for that wonderful answer. How would you describe an ordinary person's notion of scientific temper in an Indian setting?
Okay, I think half of your questions are to get me into more trouble, I think, designed to lead me into more trouble. No, I don't understand scientific temper. Okay. And I know the reason why it's invoked in the Constitution, and it's very important. And my own work on caste, etc., very Ambedkarite reading of caste and so on. So therefore, I do understand very why that was a thing, but it has been completely misunderstood and misapplied by scientists for their own political purposes. Scientific temper, if you ask me what is scientific temper, if you say that it is just being reasonable, using rational ideas of evidence, basing yourself on something called reason, I would say that it is far spread across disciplines that are nothing to do with science also. It is there in every person. You go to the vegetable shop every day. When I go to the market and they are selling these palak and stuff, there's a lot of scientific temper working there, let me tell you. In the way in which you have structures of justification, notions of evidence, making logical arguments and so on. And then I go to a science institute, which practices some of the worst caste exclusionary practices, which has prejudices against women, which has prejudices against, which has not understood what it means by merit and intelligence, which has not understood what they are themselves doing in their day-to-day work. I don't find this great idea of scientific temper operating automatically within scientists. That's all I'm saying. I'm not saying scientists have no. Scientists have particular forms of reasoning, which is very important when they're doing their work. Right? They can't just say, I'm going to offer a prayer and go turn on my lab switch and some result will come. Nobody does that. But very few people, no businessman also does that. No laborer who is unstudied does that. They don't think just, I'll go turn on the switch and money will follow from the bulb. Even if they are taught it, they'll go have put on the switch 20 times in their life. Every day, 20 times, no money falls. They'll conclude, like a scientist does, inductively, that it's not going to come. Forget it. So what is the scientific temper they're talking about? The point is that there are forms of reasoning, structures of reasoning which are present. Okay? Within the science establishment, given the practices of exclusion and caste and gender, etc., which doesn't seem to have changed the way they were doing their stuff, people have pointed out they don't find scientific temper among scientists themselves. For example, we say so much about people believing in some superstitious thing, etc. Many scientists I know smoke. And the question is, if you had scientific temper, would you smoke? If you feel that somebody who is very poor goes to some so-called godman or somewhere, some temple, put some money, or go to some godman and say, give me something, my child is ill. And you say how foolish they are, they don't have scientific temper. And then that cigarette Scientists themselves are saying cigarette is wrong or bad or whatever, and then you have many scientists smoking, does it mean these scientists don't have scientific temper? What I'm trying to say is, if there is something called scientific temper, and if scientists are the ones who are supposed to have it, I haven't seen evidence of it. When I sit in faculty meetings or sit in meetings and talk to them about any topic, I don't see them having any scientific temper because they don't base it on evidence. They say so much about philosophy and history of science, etc., thinking, oh, that's bad, this is bad, etc. And I ask them, how much of philosophy and history of science have you read before you say what you're saying? They say, no, I don't have time to read it. So you're doing exactly like what the right wing is doing. So my point is, one, structures of reason are present in different ways in different communities. Two, I don't find any special kinds of scientific temper present in science in their own interactions with people, using it to understand society and so on. Therefore, the use of scientific temper has often been used only for one purpose. It is to, as a political purpose, to mobilize people in a particular way. The science establishment has protected itself from any kind of questioning to them by saying that, anybody who questions science doesn't have scientific temper. So it's been used, rhetorically and politically. So if we have to recover, if we have to rediscover the importance of scientific temper, then we have to be more democratic about it. We have to be more egalitarian about it. Then you will discover some special virtues of scientific temper. And I know that things like certain virtues like honesty, non-fabrication, attempts, effort, all of those are important. And I'm saying that a lot of people in other domains also do that. That's all. These are very important values to have. And that is present as part of the scientific temper, but it is not something special to scientists. That's the only point I have problem with. And therefore, to use it to repeatedly put down people's other beliefs and other practices is, in my view, a dangerous one. So I find it very difficult to support the scientists on this point.
Sir, you talk about exclusionary practices in the scientific community. How can we address that, and how can we make science more accessible to the underrepresented minorities?
Yeah, again, a very important question. It's a very, very difficult question. If we have looked, not just the minorities in science are many. For many people had pointed out that a majority of scientists in India actually were from the forward caste. For a very long time, the Brahmins were the dominant community in science institutes. Even today, they are disproportionately present in all our science institutes. Now, the question is, the question is not whether they should be there or there's absolutely no doubt that they're all very competent, they have to be there, etc. That's not the question. The question is there something in the practice of science in the country which has systematically kept people out, people of other castes, other backgrounds, women particularly, out from science practices? And the answer to that is, no, we only have entrance exam, IIT entrance exam. All of you have to have been tortured to have gone through that exam to get into institutions like yours. So I feel bad for all the kids, of course, but what to do? And they will say it is just merit. We are not discriminating. If a tribal can solve, the differential equation, we will let her in. But, looking at it that way reduces education to individual capacities. And that is not true. We know that even a simple thing of lack of nutrition will keep people out from understanding and reading something, learning something, right from basic nutrition. It's not about intelligence of the mind. It's a lack of food which has driven away millions of people away from our science institutes. The exam itself is discriminatory. That's what I'm trying to say. In a world like India, in a society like India, to say I'm having one common exam which will choose, and then say, I'm not asking questions on caste and gender and religion. in my question paper. I'm not asking that. I'm just giving you solve some of these problems, differential equations. You do it, you get it. But then the question is, why you want us to solve those problems in order to get in? Why can't you take a student who is so creative with their hands, who will produce some of your best experimental apparatus? My argument has been that we have produced not such great science because we have not been democratic enough. We have not drawn upon millions of very creative minds from our rural areas. Forget about tribals and Dalits and others. We have not been able to even bring these people into our system. We have not been able to bring in the imaginative capacities of millions of girls who are very interested in science and drop out of science when it comes to higher science. And it's not that the people who are doing it, okay, and it's all apologies to the men, of course, I'm saying. It's not that all of them are duds and they shouldn't be doing it. No, they're very smart, they're very intelligent. Obviously, you guys are going to do a lot of great stuff. But is it democratic? Is it that it's just one community, one group of people have controlled this, that this is public resource? So is this the way to choose people into science institutes? I agree with you that JEE doesn't know the caste and gender and religion of the person. But why should JEE be this end-all, beginning and end-all part of entering into science institutes? Tamil Nadu has been having this fight with NEET. They have passed a bill which says we will abolish NEET. We don't allow NEET exam. This All India exam. They should do this for IIT JEE exam also, if you ask me. And you know why? When they did the report, the legislators of the Tamil Nadu government discovered that 99% of the people who wrote NEET have gone to coaching classes. And that to write NEET, students are spending up to 5 lakhs to go to pay coaching classes to write this exam. So what you're basically saying, you're not choosing students who are the best to do science. You're choosing students who have the money to put in from their 6th standard, 7th standard onwards to prepare for these IIT JEE exams. Your IIT JEE and other exams are entrance exams which need money. It is among the moneyed that you're making a distinction. It is not among the citizens of the country. It is not among creative thinkers. It is not among the potentially great scientists. No wonder we have not come through with breakthroughs in the last 70 years, because some of our greatest scientists, could have been greatest scientists, are out working in the field or driving a cow or a sheep and grazing it in the forest. We have completely lost them out. And and this is on public money. Get rid of your exams, open more science institutes. I look at IISers and stuff. I was a member of the IISer curriculum committee of IISer Mohali when it first started, because we had a very, very good director, Satyamurthy, who had, very good vision of how, IISer could have been. And it was a very good, important way to set up IISer Mohali at the time. And the first 3 years I was in the curriculum committee, we created philosophy and history of science and so on. And I was seeing IISer when it was starting, and I said, wow, what a great opportunity for our students to have institutions like this. You need 100 IISers, but not this exclusionary IISers, which look down on social sciences and humanities, which think it's only meant, and the scientists are very privileged people who can be given all this land and gated communities where they can do what they want. At that time in IISer, they were paying each student who entered 5,000 rupees as government scholarship. And I had just been working with the social science PhD students in Karnataka, etc., who were not even getting money for doing PhD. And if they had got 5,000 rupees to do PhD, they would have been so happy. So here was all this money putting into science institutes, for whom you are continuing to support people who already have enormous money, family who have supported them into this. I'm not saying all of them. A lot of people have sacrificed and come through. But I'm talking in terms of the larger democratic egalitarian thing. Can a society build great science by restricting itself to a few people? Or should it open it up? The only way to open it up is take people. No, why we are so much interested in failing people rather than passing people. Allow them into your systems. Bring all the people. You are living in Bhopal, which is you used to be the culture capital of the country. You know, some of the greatest interesting tribal systems are present there. Open your gates for them. Open them into your classroom. I'm not that they should. I'm not saying they can, just because they come into the classroom they'll be able to solve, Schrodinger's equation. They can't. But where are the ideas about great science going to come from? Maybe in collaboration with you. Or the exclusionary begins with that. It's not just about science alone. It's about these entrance tests, coaching classes, what kind of people can enter, what kind of people can survive. You remove that, I'm sure you will.
Thank you, sir, for shining light on this very important aspect. In his book, The Tyranny of Merit, Michael Sandel writes about how merit is not a good indicator of the potential of a person due to reasons you have rightly pointed out, that is, lack of resources for preparation in poverty stricken communities. What role do you think scientists should play in enhancing access to STEM and to make it more inclusive?
I think, unless scientists recognize that science education in the true spirit sense of the term is not a discipline education. That is, you want to produce great scientists, don't tell them it's only what is being taught in your physics, chemistry, maths textbooks. Science is about observation. Science is about teaching people how to see things in the world, how to discover new qualities in the world. That is also taught a lot from art institutions. So the first way in which I really think we can tackle this problem that you raised is to say, open up your schools. Today's schools have become so science heavy. They have stopped teaching other courses. They don't pay attention to teaching literature, social science, moral science, none of that stuff. I know in schools in Bangalore, 6th standard students are going into IIT coaching after their class hours. They go from 6:30 to 6:30 every day. Every Sunday they write an exam. What is called an all India exam. One kid who's in 6th standard once, and I went to her house, some relative of mine, she said, "Oh, I'm AAR 300 or something," she said. And I said, well, I had no clue what she was talking. She said, her mother said, "Oh, next time you will become better." And I said, "What the hell is this AAR?" She said, "All India rank." 6th standard, all India rank. Every Sunday they are creating morons and robos like this. Writing all India and exams, competing with each other, telling you are ranked in this. And, the whole aim is to get through your exams. Abolish these bloody exams. Throw them out of the window. I'm telling you, really. And it's not even merit. It's not even tyranny of merit. It's nothing meritorious about, yes, it's skill. There is skill based. You're doing something great stuff. I'm not denying that. But you want great science, that has to go out. And so how can scientists help it? By first making science teaching in school, teaching in science very holistic. In fact, when I have talked to great scientists, really creative, very good scientists, people who have made great, mark in science, they have all been, very interested in music or poetry. They have read a lot of stuff. They're never one-dimensional as we are making our children today, because they did 100 things as they studied in school, college, and became great scientists. They did not become great scientists because we had schools like we have now. And imagine, I'm just shuddering to think in 20 years, these kids are the ones who are going to be scientists in 10 years. None of our great scientists in India and abroad too ever came from school systems like this. So the scientists should lose their obsession about STEM and just understand education. Education which is democratic, which is egalitarian, which produces dignity to students, and exposes them to as many influences as possible. And don't worry, any of them who do science will do good science. That's all we have to do. We are running a rat race which we are not going to win. We can't compete with the West on this or China. That's not the race we should be running. We should go back, and it's a scientist who can do it. It's a scientist who have been pushing the removal of so many subjects from school and college curriculum. Scientists should just understand education and insist that school education has to be changed in order for better STEM education.
Thank you, sir, for your valuable insights. So, contrary to popular belief, you describe science as an inherently social endeavor, driven by collaboration among scientists specializing in these various domains of STEM. So, could you elaborate on that? Why is it essential that we perceive science as such?
Yeah, I think a lot of my question answers earlier have actually touched upon this, that science is, it is not produced by an individual. For example, for any of your students at IISc Bhopal to be able to enter a classroom like that, you needed a government, you needed a state government, you needed a central government to do it. You needed earlier visions of people like C.N.R. Rao and others who said you should have things like IISc. Then you had various number of people who headed such institutes and thought about it and said, let's build a structure like this. Then you have, as I said, curriculum committees and so many committees which will set up your syllabus. So the point is, when you enter into the classroom and sit and listen to one class, it is not because of you. It is because of million forces which have all enabled conditions for you to be able to sit in the class and listen to one lecture. Imagine what's happening in Afghanistan if the Taliban reject, let's say, cancel science classes tomorrow, not just for women, say nobody should do science. Then none of you may all be greatly interested in it, you'll never be able to learn science. So enabling conditions are very important. And enabling conditions are produced by society. I tell children, many of whom, they feel, oh yeah, I have to go prepare, I'm smart, etc. I tell them, look, the fact you should be thanking the maids in your house for your intelligence. If the maids had not come, cooked your food for you like in some houses, or taken care of, cleaning your room and your house for you so that you can sit and do some maths problem. Most kids don't have that. So, or your parents doing all this work for you. Everybody is working to produce one individual who can write this stupid exam. So what I'm saying is the sociality of education is that you need all these factors working together to make it happen. And science, in that sense, is intrinsically social. Without that large social structure which enables it, it's impossible to understand what science is. And the practice of science also recognizes that. That is why you have these journals, you have reviewers who read the journals, so somebody who publishes it, etc. You're constantly with a community, with other people who are making decisions on what you have done, and so on. So reducing science to some intelligence of an individual mind is an extremely flawed understanding of science. There may be truth about some really unique minds, like maybe Ramanujam and people like that, which comes once in 1 century, you'll have 1 or 2 people like this. That's not science. The science is the 3 million papers and 30 million papers which are rejected and 3 million papers which are published. Science is the whole army of ants who are all producing this little bit of work so that somebody is going to get a Nobel Prize somewhere, sometime down the line. That's what science is. And it needs a whole society, it needs nature, all of nature to be able to allow you to do this. And therefore, they should be answerable to the society. That's the whole point.
Thank you, sir. That will really help us look at the bigger picture here. Now, talking about ethics in science, you have pointed out that curiosity is the one notion that allows science to keep ethics at bay. However, an appetite for curiosity is essential for doing science. So, how can we ensure ethical accountability in this context without compromising on what drives science itself?
Yeah, I mean, it's again a piece of work which I had done earlier, and I wrote a piece called Science and Ethics of Curiosity as a response to my constant struggle with scientists. Because when we talk about the good and positive aspects of science, the scientists would immediately respond by saying, "Oh, a knife can be used for cutting vegetables. It can also be used to kill." So it's not the knife's mistake; it's the person who is doing it whose mistake it is. So the atom, what can Einstein do? He just discovered E equal to mc squared, but it's the politicians who are dropping bombs. I mean, the whole story is anyway wrong, but that's an argument that they keep using, but in pure and applied, etc. So I was trying to find out the way to answer this, and there are various ways to answer it. And then I stumbled upon this whole thing about curiosity and how to understand curiosity. And what I realized was that curiosity, it's a very good example of a kind of historical thinking. Every concept has been historically formed. Curiosity in the medieval ages was actually a bad virtue. If you are science students in the 16th, 17th century, still they would say, "Don't be curious." Curiosity is actually a bad quality to have. Maybe like lying is or whatever. Lying now no longer is in the post-Trump era, but let's say something else is bad quality today. We may tell children those days. In those times, if you say, "I'm curious," they say, "No, bad, 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 bad child. Don't be curious." Curiosity, like all concepts, get changed by various social forces, and the creation of science is a way in which, the way I call it, is rehabilitate curiosity, give value back to curiosity. Okay, it's a long story. You should read the piece. It's in Current Science. It's a general reader thing. It's called Science and Ethics of Curiosity. So I'm not saying curiosity itself is right or wrong. There is no word, there's no one meaning for curiosity. Curiosity, the meaning of curiosity, like all meanings of every concept, is given in that time. Every concept has its meaning in a different era, which is very different. So curiosity today is very much important for science. But the problem is it has allowed people to say, "Oh, I'm just curious to see what is the most powerful virus I can produce in my lab." I want to tell that guy, "Sorry, dude, you don't have any right to be curious about that." When people are searching for this God particle or whatever, the Higgs bosons and so on, there was a discussion. There was a time at which the CERN had also stopped its thing, because there are two French physicists, if I remember right, it had happened some time back, who had written a paper saying that if they go ahead with that very high energy collision, there is a possibility, there's a theoretical possibility of a very small probability that a small black hole could be formed at that region. And the nature of a black hole is it starts expanding. So what we're basically saying is, by doing this very high energy experiment, there's a very, very small probability that the Earth could be eaten up by the black hole. And it was published as a paper, and immediately everybody started jumping at them, and somebody had to say no, etc. My point is, if there is even 1% probability that the experiments you do can destroy the world, what gives you the right to do that experiment? Why do I think I need to know that knowledge? Whatever you think is that knowledge. What price the knowledge I produce? Look at what we have done to the world today. Shouldn't scientists be worried about it? The absolute destruction of basic health parameters. What is this knowledge for, guys? I don't get it. What is this production of extreme amount of knowledge for what purposes? At what costs? That's the point. So curiosity now, I think, should be curtailed back. In the name of curiosity, I'm not saying curiosity should be curtailed back. In the name of curiosity, you cannot allow these kinds of things to be done. And science has to be a bit careful when people can misuse it for these purposes.
That is a very, very intriguing idea. So, now coming to science education as it stands today, how can we improve the way we teach and communicate science in India? What roles and responsibilities do you think scientific institutions have in engaging younger students and society in science?
When they're talking about young people, as I said, again, we had covered some of this aspect on science education. I think good science education needs good education, not science education. Good education means you learn as much, I'm not saying you don't go to school just to learn content alone. You learn 100 other things. You learn how to behave with others. You learn, even a music class can go into producing a great scientist. A theater class, a music class, a drama class, sports. For heaven's sake, we have stopped kids from playing in the bloody field in our school today because they have to do 100 science classes. That is, you want to produce good science students, liberate education. Give them good education, an open thinking, living with nature, and ethical education. You give them that. The content you can always teach and you can always crack it there, not a big deal. Content is the easiest thing for you to teach and do. Give them that environment of good education, which is also ethical and respectful of other classmates, respectful of social differences, etc. Then I guarantee you, I'll give it to you in writing, the kind of science India produces in 20, 30 years will be of great quality.
Thank you, sir. We really appreciate your fascinating ideas. Are there any concluding words you would like to address to our audience?
No, and hope I'm not making more enemies after this. That seems to be the consequence of all the talks that I do, at least among scientists. I'm sure that it's all open and it's a great forum. I'm so glad that, you had produced these kind of questions. And because you were like this, I took the liberty to be more open and share these thoughts. But again, as I said, the only point of what I would like to tell science students is, you have such a great impact on society. You will have the kind of work you do, the things you think of, and which we'll all feel the effect of it. And therefore, you have to be more, in some sense, more aware of your position in the world. That's all we are trying to say. When we say we want to talk about science and stuff like that, it's not about every scientist. As I said, some of my best friends are scientists. They're wonderful people, and so on. My father himself was a scientist. So, somebody who has inspired me a lot. So I know exactly, the things about this. But the flip side of it is as a social phenomenon, not as individuals. I never talk about individual scientists. I only talk of science as a social phenomenon. Right, as an institutional social thing. There, we can be worried about certain trends, and therefore bringing these questions of thinking about science, opening up your own capacity. Like as I said, the fact that you can go sit in humanities department, take very interesting courses which are completely useless in your lab. That is the one which will give you a great idea in 10 years from now. And why am I saying it? Just because I'm trying to sell humanities? No, because I'm drawing upon case studies from history of science. Some of the greatest examples of science have all happened that way. So if you had read history of science, you would have recognized that. So it's not that we are pumping for humanities and music classes and theater and sports. I'm just saying that's what's been empirically given to us. So like a true scientist, I want to look at the empirical data and ask, how do we produce better science? To me, but this is my own last point I want to say is, I'm not as much excited about the brilliance, intellectual brilliance of scientists, as much as I'm interested about their human nature. The fact that they can be good citizens, people who are producing innovative ideas, innovative technologies, in a sense which betters the society around them. That is a great vision of a science. That's a vision of a science which India can uniquely produce down the line. I do believe that it is possible. But thanks to all of you for this wonderful open discussion. And it's been a great pleasure. And maybe we'll continue the conversation sometime.
It was a real honor discussing these ideas with you. Thank you so much for your time and patience. I'm sure this episode will leave our listeners with much food for thought.
Thank you so much.
Thank you, sir.
Thank you all. Bye.